Hello there. Today we will be doing longest common subsequence. This is a 2D programming problem, 105 of 150. It seems like we're moving pretty slowly recently, but I should be able to speed up today. So, in this particular problem, we're given two strings, and we want to know the common subsequence. What does this mean? So let's say we have A, B, C, D, and E. We see the common subsequence is A, C, and E. With that, I think we were able to find that the longest common subsequence was 3, as you can see here. So how do we do that? One way is to, the way I do it usually is I would go forward. So what does that mean by going forward? That means I have zeros in place in a grid. So that allows me to make sure that I am performing the correct operation on the correct character to build up or build this solution. So what does that mean? So look at A and A. If it's 1, oh whoops, we need one more row, my bad. So we have A and A. We look before it diagonally. If they're equal, let's put 1 in there. Otherwise, let's just pull from the left or the bottom. If they're not equal, just pull from the max of the top or the bottom or the left, which is going to be 1 and 1 and 1. Same here. And if they're equal, we'll take from the diagonal and put 2 here. And then you just keep building this up very simply. And eventually, the things equal here. Just pull, and keep pulling. And they're equal, and then you put 3. And that's how you get the solution. Where there is something equal, you take it from the diagonal and add 1. And when they're not equal, just pull from the left or the top. And this way we can build up our answer, because every time we match, we only match it once per a line. And we don't match it more times than that, because we match it from the previous line. That's the logic there. Another way people tend to do this is do it in the opposite order. So they do it from the bottom up. So that means you have the same thing, A, C, and E. And then you have A, B, C, D, E. Of course, you fill these out with 0. But as you can see here, they start from the other side, from the E, and they just build this particular solution up from the bottom right-hand corner. So we take, there's one more row. So we take, if they're equal, go to the right diagonally and add 1, and just take from the left or the bottom. So same here, and take from the left and bottom, take the max of that. And once you get something that's let's say equal, same logic, because it's because we're taking from diagonally, we can only take it once, so we don't take it multiple times. Suppose you have 2 C's or 2 A's, we don't take it multiple times. We only take it once. Hopefully that makes sense to you. So basically it's the same here. 2, take it from the bottom left, take it from the bottom left, take it from the bottom left, and take it from the diagonal, because they're equal. And that's how we get this particular solution as well. So, oh, whoops, that's not good. Well, anyways, we have 2 solutions now. Looks like that solution is going to be like that. We're gonna program both solutions, and just find out which one's better to code in an interview. So for I in range, length of text of 1, this is gonna be the rows. And what's gonna happen here is that we need to create number of columns in terms of text 2. So this is a little different from our this particular item because our text 2, well, it's actually correct because text 2 is ace and text 1 is the column rows. So we're good. We're good to go. All right. So what's the problem here? There it is. Right. So with that, we can do a while loop going forward. We take the first item and we go down to the length of text to the last item plus 1. So, and then we do the same for j. So if text 1, I minus 1, because we are moving one step earlier than our I and j, so we need to move it one step back. So dp of I and j is equal to 1 plus the diagonal of I minus 1 and j minus 1. Else, we just have to pull from the top or the right. So dp max of dp of I minus 1. So that's from the top, or dp of I and from the right, from the left. And then all we need to do is return dp of -1, -1, which is the last item in our dp. Pretty quick code. Let's run it. And we are good to go. All right, let's copy this code and basically run it in the opposite order. So same thing. We have to get the dp's. Let's move this up a little bit so we can get some more room. Same deal. So instead of going to the right, we're going to go to the left, and we're going to lose one of the rows. And same here. So 2 lines of code down. Let's take a look at the third line. The i's do not need to be subtracted because we start from the last item of the text, no problem. dp of I and j, no problem. 1 plus, it's addition rather than subtraction because we're looking to the next line rather than the previous line. Same here, we just have to do a plus here instead of a minus because we're going to the right and to the bottom. And instead of getting the last item, we get the first item, and let's run the code. And we're good to go, and this is the second solution. Right, so that is all for this particular problem. Let me just edit out my face, and now we have 2 solutions to this particular problem. Let me get both pieces of code in make both pieces of code visible to you. Perfect. Hopefully what we learned today is that we can build up these solutions from the top right hand corner and the bottom right hand corner, and top left hand corner and the bottom right hand corner, where we could actually build this up with 2 lines, because we just need the previous line and we'll build up the current line, and then we just have to swap those. But this makes it a lot easier to code out, and we're not using too much. We're using as much memory as our time. If memory was a factor, we could look for a way to what we did previously to create new rows and create 1 row and start from a single row and build up these solutions. That's also a way to do that. So I hope you learned something today. If you enjoyed this video, like and subscribe. If you want more, check the link in the description below. Thank you very much, and I'll see you in the next one.